y'all. Let's wait for like 5 minutes, let other people join, and then we will start the workshop. And then yeah, let's just wait for like 2 3 minutes, and then we will start the workshop. Really excited for this workshop, and yeah. All right, people are joining. That's cool. Let people join. I know it's 11:59, so we're just gonna wait for 2 more minutes, and then we can start the workshop. All right, sounds good. I see some comments. Let's go. Yes, sir. Let's go. Let's wait. Okay, sounds good. All right, guys. So let's start with the workshop. It's 12 right here, 12 p.m. Eastern. So just quick background about me. I am Jahanze. You can call me Jay. I'm developer relations engineer at Coreum. Usually just handle all the technical side here, building a lot of stuff, do workshops. So yeah, that's just about me. And then today, the goal for the workshop is that we're gonna talk about two things. I'm gonna explain you what are the static NFTs, and then I'll explain you the dynamic NFTs. But the workshop, we're focusing only on dynamic NFTs because I, I'm aware that obviously that you guys should be aware of static NFTs. I mean, I'll explain what are, but still I will explain what are these static NFTs, and then we're gonna go ahead and understand what are the dynamic data and what are the dynamic NFTs. So let's start with the presentation. I will just quickly explain the presentation. I'll just slideshow, and then later on, obviously, we're gonna do some coding. I have actually built two applications for you guys. One is on Golang and React, and other one is on I built a contract, and I've also integrated with the Next.js application. So I think that's gonna be a cool workshop. So let's start. So gonna be showing. Okay, actually having some issues. Okay, I guess there's some issues. Okay, cool. So I think do it like this, having some issues. But okay, so static NFTs are you can think of as immutable data. Is a fixed content. Once created, the data of static NFT remains unchanged. So it is a permanent record on blockchain. You cannot change the metadata for the NFTs. So these are actually static NFTs, and we use something called dynamic NFTs. So we have actually introduced this feature in our smart tokens. So now these dynamic NFTs can be referred as mutable. So these are mutable data and changeable data. So these dynamic NFTs can change their content or metadata over time based. So so today, obviously, I will show how dynamic NFT works and how you can change the data. You have to specify class ID and NFT ID. I will show you, explain you how everything works. We don't need to be worried too much about this. Some use cases for static NFTs, guys. Some use cases you can think of as limited art collection. You can have this art collection as an NFT, and it's going to be permanent on blockchain. The data will be uh, also be permanent, so you cannot change the static NFT data. And then we have some tokenized sports auction cards. Some LeBron James, Steph Curry, and these are the cards that are also permanent. The data cannot be changed. There's so many tokenization platforms that are doing this. Even OpenSea. There's a lot of cool platforms. And right now, as you guys know, that bids are going to be introducing the NFT marketplace. So I'm really excited for them how they're going to introduce dynamic data NFTs in their platform. So let's go with update dynamic data. So this is you can think of as like a metaverse. So imagine you have a plot of virtual land, and over the years it is for example, the first year it has like 2 3 rooms, and it was just a small land. And later on, after 3 4 years, the land got bigger. You built some rooms, you built a basement, you had a lot of different stuff. So maybe after 2 3 years you think maybe I can change the data. I can change the dynamic data. I can do some land modifications and include this in my blockchain. So yeah, I mean, that's how you can change dynamic data. So it's really cool to have this feature on the blockchain, because there's so many different use cases that you will be needing to change your metadata, and that's where dynamic data is going to play a really important role in blockchain. And similar for update dynamic data use case, we have for example, I'm just going to give an example for gaming character. There is a warrior character in a game that gains, for example, experience points, levels up, learns new skills as the player progresses through the game. Obviously, you're going to see how that there's new skills of that character. Obviously you're going to be leveling up. There's going to be experience points, and that's where dynamic data or update dynamic data feature will play a huge role. That's where you can obviously uh, change the experience points, can change the levels, can change the skills, and obviously you can change the equipment. And yeah, so that's the difference between static NFT and dynamic. Just to quickly summarize what static is obviously immutable, cannot be changed. And update dynamic data is mutable. That means you can change the data later on, even if you want to change, for example, after a week or after a year, you can definitely do it. But obviously, within the smart contracts, you need to specify, okay, this is actually a mutable uh, data or mutable NFT. So later on, I'm going to show you how you can do that. No worries. We don't have to stress it out right now. I know it's going to be a little bit too much. Okay, so let me just go back. Let me see if there is any questions. Okay, there's no questions. That's cool. Okay, so now let's jump in the a little bit stressful, I would say it, or I will just show you contracts and show you the interaction of the front end and the back end, how you guys can build cool stuff on Coreum. So I'll be just give me a second. I will just show you the screen. Okay. All right. So right now we're just gonna be focusing on the smart contract right now, and then I'm gonna show you the UI. And all right, so as you guys can see, this is a COSM VASM smart contract on Rust, obviously. And within this, our source file, you can see there's a lot of different stuff. We have contract, that's our main contract file. We have some errors. We have lib, this is called library. Obviously, we're just importing all the modules. And this is our messages where we have different enums. We have struct, which is our instantiate message. We have execute message, and we have query message, which I will explain you right now. Just gonna go through these files, and these are the state variables. That's where we're just storing our states, and these are the test cases. Okay, so let's start with these states. So these are the state variables. So right here, I'm just specifying and just importing this crate. So this is called CW storage place. Within this storage place, I'm actually calling this item. So if you see this item is a struct, it has a storage key, and it has a data type. So it basically stores item you can think of as one type item. You can store one type item at the given key. Basically you can think of as like a singleton storage, right? So here we're just saying public const class ID, and we have an item string. We're just giving a generic parameter. Within this, we're just wrapping with a string, and obviously we're just going to be saying item new, and we're storing the class ID. So these are, I think, this really basic state variables here, guys. And here we have a messages. So I think this is really important to understand. So we obviously have different stuff right now. We have imported some different crates. We have asset NFT, burn class response. We have different kind of stuff that I have specified. And then we have query responses from CosmWasm schema, that where you can query the responses. And then obviously this is a binary where you can obviously is a wrapper. This is like a wrapper around your vector, which is used for this, which is represents a array. and then obviously is adding a base64 serialization. So we have a struct. Within this struct, this is basically a struct you can think of as a structure, data structure. Within this data structure, we're just specifying as public. We are specifying name, symbol of the NFT, obviously, description, the URI hash, data, features, and royalty rate if you want to obviously specify it. And then we have execute messages. So later on, I'm going to show you how I'm going to import these execute messages in the contract, and you can actually within this function of execute, you can call these and you can match it. For example, if it's min mutable, so it's going to be called in front end on UI, it's going to be called min mutable. It's going to be min immutable, that cannot be changed. And then we have modified data, which will be used to modify the data later on. Okay. And then these are just basic querying the responses. These are the attributes that we're using. We're just specifying just for serialization and deserialization, and here we're just giving it enum just for querying purposes. We're just going to be querying later on, and then these are the params, classes, balance, owner, supply, all that stuff. And then, yeah, then let's go to the error. And this is the contract error. Then I will be showing you how you can use these contract errors. We're going to go here and let's understand this contract, you guys. Right here, we have imported all the necessary modules. Just to let you know, I have imported the state variable, obviously the one I have created. I'm going to say use create state, and then I'm obviously getting the class ID that I just showed you how I was using item to store this key. And here I'm just importing my execute message, instantiate message, and inquiry message that I just literally explained you guys, similar for errors. And here I'm just importing other necessary modules, or if you have entry points, we have JSON, Cosmos message, dependencies. This dependencies refers to your, within this dependencies, we have storage, we have API, and then we have querier. That's a wrapper. And then this is called dependency mutability. That means that dependency can be changed. Remember, mutable means it can be changed. And this env refers to this block, info, transaction, contract address if you want to get. And these are the message info, these are query requests, and these are the response, which is going to give you response while instantiating a contract or executing or migrating a contract. You're going to be using this response to tell, okay, whether this response has been okay or no. So that's what we'll be using. And then obviously we have a standard result. Standard result is basically nothing but just wrapper around your result. So result gives you okay and error. Okay. So we have two functions. We have actually a lot of functions there, but we're going to be focusing on 4 functions. The first one is really simple, guys. Here we are just instantiating. You can think instantiating as a constructor, like maybe you can think of as that way. And we are just instantiating our state variables. You guys can see how we are instantiating. This is our parameters, just having our own whole parameters. We have instantiate message info in env, and then dependency mutability. And this function, instantiate function, is actually returning a Coreum result. And within this, we have a wrapper. If there's any error, that's actually gonna return you a contract error. Okay. And then we are just setting up our contract version, which is a contract name, and there is a contract version. And here we're just initializing the owner. And obviously we have to initialize the owner. If you're not going to initialize, it's not going to understand while instantiating. And then we have this issue message. This is really important. We are issuing a class of the NFT. So this is a message, which is a part of Coreum message. If I go quickly, go to the definition, it's going to show you the Coreum messages. We have 3. We have asset NFT, we have asset NFT, and then we have NFT. Right now, we're dealing with only asset NFTs. So within this asset NFT, we have asset NFT message, and that's where we're using the issue class. Okay. And I will go back to the contract. Here I'm just literally just calling this asset NFT. Within this asset NFT, I'm just calling issue class and specifying all the necessary parameters. And this class ID, we're just formatting this class ID. We're just specifying the message symbol, contract address, and we're just gonna say this class ID will be just lower case. this class ID will be, I'll show you in the front end how this class ID is gonna make sense. Right now we have to specify a class ID for an NFT. Once specified, we're gonna save the class ID into the dependency storage, and here obviously you have to specify the reference of the class ID. Reference, there's ownership concepts in Rust, which is a borrowing. So we are actually borrowing this class ID. We're just giving a reference to this class ID. We are not copying it. We don't need to copy this. We can only take a reference. And that's why we are doing right here. Once everything is good, then we're just going to have a response for, we're just going to have attribute, we're going to have add attribute, and we're going to have add message. This will give you a response. If everything is good here, it's going to trigger and it's going to show you a response as mentioned above in this function. This is actually returning a result. So result obviously have okay, error, right? We have two things. We have okay or error. Within this okay, we have this response, and then obviously we're just going to be using response, just calling a new response, and we're just adding attribute, which is a key and value, its owner and info dot sender, and yeah, and then we have different attributes and messages. So hopefully you guys understood this concept. Really simple. It's really simple to instantiate a function. And let's go, before jumping to this function, guys, I want you to guys understand three functions, because in this execute message we are actually getting one, two, and three. We're actually returning these three functions: immutable, min mutable, and modify data. Okay, but we're gonna only care about min mutable and modify data. Okay, so let's understand really quickly about this min immutable function. Within this immutable, sorry, we have different parameters. We have dependencies, infos, all the basic stuff we have to specify, obviously. And then we're going to have a recipient. Obviously, when you're going to mint, who is the recipient, and there's data. What is the metadata? What is the URI hash? What is the URI and ID? And here I'm just specifying the assert owner. So this is like, you can think of as asserting and checking the dependencies in from the dependency storage, and we're just going to specifying the info.sender. Okay. And here we're just loading our class ID from the dependent storage. If it loads, then it's good. And this question mark is used only for error handling purpose. It's gonna throw an error if there is any issue while loading this class ID. Okay. Hopefully that makes sense. And this is basically really simple. Here we're just specifying data, and we're just matching this data while whether if there's a sum if there's a sum of value, and obviously here we have data, you can think of as a value here. And if there's a sum of data, we're just going to return a data bytes in immutable. Okay, so this data bytes can represent the immutable data. You cannot change this. You cannot change this, guys, because this is a min immutable, refers to static NFTs. And here, obviously, I'm just doing some mapping, validating all the addresses, transposing. The transpose, while we're doing transpose, at the moment, once we are doing mapping, we're getting this option result address and standard address. What we have to do is, guys, we have to transpose this in this format: result option type and error. So this is gonna give you okay, sum, and then you're gonna have type and error. And then obviously we're gonna unwrap it. Unwrapping means we're gonna unwrap the value. If there is successful, obviously it's gonna unwrap. If there is any error, it's gonna panic. Okay. So this is basically simple message of message mint. We're just minting our message as mentioned, and later here we're just converting into protobytes, because that's how you have to convert this message into a protobyte format. And here in our Cosmos message Stargate, we're just specifying two types, right? We have type URL and value. Within this Cosmos message, we have different stuff, right? Let's go quickly and understand. Within this Cosmos message, we have bank, we have custom, we have staking, we have distribution, IBC, VASM, and governance. Bank is refers to sending, right? And this custom, this staking, right now we just only care about Stargate, and that's where we're using. We have to specify the type URL and also the value. And that's what we're literally doing. We're just specifying the type URL and value, which refers to binary from min bytes. And once it's done, then we're just gonna trigger an event, which is obviously a response. We're gonna create a response, we're gonna add attributes and add messages. So that's referred to a min mutable, guys. This is basically immutable. That means it cannot be changed as mentioned in the function. Okay, let's go to this min mutable, and so this is basically our min mutable. Same stuff, but understand this here in this message, guys. We were using data bytes. That refers to immutable data that cannot be changed. That's important. And then in our min mutable, if you see right here, the functionality is same, by the way. There's no difference, but there's only one major difference here, guys. While I'm specifying this data, you can see there's a data dynamic, which allows us to change the data if you want to. Here we're specifying editors and data. So editors will actually allow us to mention who is the editor and who can change this NFT data. And we obviously are specifying editor as admin, and only owner can change this NFT. Obviously, if you're minting, if you're the owner of this asset, only you have the right to change the NFT data. And here we're just specifying the NFT data. And here, once done, we're just gonna be saying to any, which is a to any. It's gonna refer to as to any, and then we have none equals to none. And similar stuff with this functionalities, we have recipient, we have message mint, and then we have similar stuff. But always remember, we always have to specify this data dynamic while you're building a dynamic data, so we have to specify this data dynamic. Just remember this. The function is similar to the immutable, but the difference is here immutable is data bytes, and mutable we have data dynamic, which allows us to change the NFT data. Okay, similar functionalities. And let's go quickly to modify data. Okay, we have the same stuff. We're just loading our class ID. Here we're just modifying our data. We're just saying sh update data. Within this, we're just specifying all the simple stuff, right? You can think of as we have message update, which is gonna define message to update the dynamic data, obviously, and that's what we're literally doing. And yeah, similar function, guys. This is similar concept, and here we're just specifying data dynamic. You just have to specify the data, and yeah, I mean that's what we have to do. And this was simple, I guess. Hopefully that's simple. One quickly to show you guys. Once you have built a contract, once you have understand the contract, I have also created the schema files. So I have created the schema file. Later on, I've used this to generate these type scripts. And you can see how, if you want to like obviously generate these type scripts, I will just go to the documentation really quickly to show you guys how you can also generate these type file. Go to this documentation, go to get started, go to the wasm, go to the using cosm.js with wasm contracts, obviously install, create your schema files, run this file. And this is the important, right? I'm gonna copy it, show you how it works. Just copied it. I'm gonna go to the contract, gonna go to my terminal, and I'm just gonna plug it in, and boom. Yeah, once I ran this, so it's gonna create a TypeScript generated files. But this is client file. Okay, this is the client file which will be used just for to interact with our Cosm Asm contract. As you can see, it has already generated these files similar to these types. You know, it has generated the data structure for us. Later on, I'm going to show you how you can interact with these structures. And yeah, it's a huge file. Obviously, our contract was big. So let's actually go to now. Once we are done, guys, we can close this contract. Let's see if there is any questions before. Okay, please, can you give me some tone? Please, hello, brother. Okay. Okay, there's no questions, guys. Okay, that's cool. Now let's go to the front end UI. That will be fun. Okay. So now, just to quickly understand how it's working, so what I have done is this is my Next.js application. Within this next application, I have just specified the contract, client, and types. That's what I have mentioned as in the smart contract. I just generated for you guys to understand how it's working. It just generated first, and now what I did was I have just included this file in my Next.js, and these are the clients types. And let's go to the pages, guys, to understand how I'm actually interacting with my application. So here is the cool part, how you can interact. Here I have specified the contract addresses, and this is our main function. And within this main function, guys, we have state, use state, which is used for state management. And on the above, the top side right here, we're just specifying our chain context and wallet address. So this chain context is coming from use chain. This use chain is part of Cosmos Gate. Sorry, just give me a second, guys. Sorry about that. All right, so we are using this use chain, and this use chain, I can show quickly what that means. This use chain is actually getting the chain context. Actually, you know what? Let me show this again. I have gone to the, let's go to the definition. Okay, so now if you see right here, we're declaring a const. I'm not declaring it, just a part of Cosmos Kit, by the way. Within this Cosmos Kit, we have chain name, and then we have sync. The sync question mark refers to, it's up to us if we have to specify sync in the main index. And we're gonna go to this chain context. Within this chain context, guys, this is the interface. This is actually extending this chain context wallet, and you can see there's so many other functions, right? And I'm gonna show you how we're gonna take these functionalities. Okay, and then we're just specifying our wallet address. Here we're just specifying the state variables, how you can mint, how you can do modify NFT data, all just for state management purposes. Okay, and then later I'm gonna show you. Later I'm gonna show you how these state variables gonna play an important part. Sorry, and then here we have a use effect. Within this use effect, guys, we are just calling a condition, which is a condition of wallet address. If a wallet address, then we're gonna have a function. So this you're gonna be wondering what is these what are these parentheses, right? This parenthesis and this parenthesis. This is called immediate invoke functionalities in JS. Hopefully you guys understand this. This is part of JS, and that's how you can call it within this. It's really cool. Here within this functionality, within this asynchronous functionality, we are specifying our basic stuff, specifying signing client, which will be used to sign, and here we're just updating our project client with our client wallet address and contract addresses. Here we are going to be creating handle and NFT action. Okay, within this handle NFT action, we have a standard fees. Okay, that's going to be used for obviously gas or amount, and here we're just encoding it, and here we're just using try catch to understand if there is a transaction method, if it's an action. We're gonna mint. It's gonna be mutable, and it's gonna be, or else it's gonna be a client dot modify data. So this is like a ternary operator that you guys can use. Hopefully you guys understand what is this in JS. So this is like to understand. This is like a shortcut for if or else conditions, right? Question mark or colon, right? If it's mint, it's gonna give us this. Else, it's gonna just modify the data, right? And then we are doing the similar stuff here, and we're just also gonna be doing the same thing here. We're just getting our transaction method. If there's a transaction method, went perfectly, there's gonna be a toast of success where it's gonna show you a transaction hash. Similar with this. If not, it's gonna throw you an error. Okay. Here we have all the simple CSS, guys. I have so many stuff. I'm calling this header, which refers to a wallet that I have already built. Let's go really quickly. This is basically your header. That's how you can connect to different wallets. We have connected this. I think we have explained you guys a lot of times what is this in a lot of workshops. And here we have different buttons for mint NFT, for modify NFT, and then This the button used for to mint the mode. We're just using on click and set is mint to mode is equal to true, which is obviously if there's a mint, obviously it's gonna be true. And then this is we're just using simple CSS, and this is the function. This is the button same for on click, and then we have different inputs, right? Inputs obviously for modify NFT. Let me show you how the UI looks, guys. So that's how you guys can understand what is actually happening. So let's go to the local host 3000. So this is basically our modify NFT and mint NFT. So now I will just disconnect my wallet, connect the wallet again. Gonna go to the Kepler. I've connected my wallet. So as mentioned in the application, guys, these are our inputs, right? These are the inputs. We have placeholder for NFT data, NFT ID. We have different inputs, and that's literally what that is. That's literally what it is. So right here, we can give this NFT as anything. We can say unique NFT 222. NFT data could be hello world NFT URI. We can just get any URI basically. Okay, we can get this URI for Coreum. I'm gonna go right here. Just gonna put hash 2. We're just gonna mint NFT. I'm gonna show you how that's gonna work. I'm gonna say mint NFT. Now I'm actually approving this transaction. You guys might not be able to see it, or might be able to see it. I'm just signing the transaction here. Just gonna approve, and you're gonna see this transaction hash. Right now, let's just show you how this is working. We're gonna go to the block explorer. By the way, I'm just doing everything on testnet just to let you guys know. And we're just gonna copy this transaction hash. I'm gonna see how this works. If you guys can see this message, right? This message refers to this data. Data is this right here that we specified. Let's go to the base 64 and just copy this data and go. And as I mentioned, this is the data was hello world, right? And that's what I did. You can see this is the contract. And now, guys, the main part. Now let's modify the data, right? NFT ID. Man, remember one thing really important. So this is our NFT ID. So this is already minted in our blockchain. If you're not gonna specify correct NFT ID, it won't modify. So this is really important. So this NFT ID refers to which is the NFT. It's gonna be easier for blockchain to know. Okay, this is the ID that will be used to update this dynamic data. Okay, and that's what we have to do. They just have to copy this ID because that's what we have to update, right? And that's what we're doing. So I'm just gonna refresh. I'm gonna have already copied this NFT ID, and I'm gonna say the best enterprise grade blockchain, and I'm just gonna be modifying this NFT data. By the way, now I'm here, just gonna copy this. Not gonna copy right now. I'm just gonna approve this transaction. You guys gonna see the hash of it. Okay, boom. Okay, the transaction has been successful. We're gonna go to the block explorer, guys. We're just gonna search for this transaction hash. As you guys can see in the block explorer, the result has been successful. And as I told you guys, we have used this NFT ID in our modify NFT data, right? We have specified it, and exactly that's what it did. Remember, the first data was hello world, right? And now we're gonna see copy this data, right? This data refers in bytes format and base 64 format. And here I'm just gonna decode it. Boom. And look, that's what it's showing me, right? The best enterprise grade blockchain. So how cool is that, guys? So now you are gonna be able to change the metadata. You can now, I have taught you guys how you guys can build an application, right? You guys can, I have gone through the contract. I have gone through the code, how you can interact with the CosmAsm contract. And that's what we are literally doing, guys, here in our smart contract and in our functionality. Okay. So hopefully it made sense for you guys to understand. And now I'm just gonna close this application because obviously we have gone through this, and now we're gonna go to the little bit harder part. I would say we're just gonna show you how the Golang, how I have built the HTTP server, and how I have built a backend to interact with our React. So I think this is gonna be a new concept for you guys. I know we haven't taught you guys Golang, or we haven't taught you and or gone in depth of Golang and how you can build server and how you can actually interact and can do the similar stuff with the Golang code. Okay, so I'm just gonna just close this my application. I'm just gonna make sure my ports are clear. So I'm just gonna check. Okay, I'm just gonna kill something here really quick. I'm gonna copy this. I'm just gonna kill it, and now I just don't need this. Okay, then I also don't need this anymore. Okay, so this part of the application has been done, guys. Hopefully you guys understood. Let's go to the questions really quick to understand. Uh, okay, we don't have any questions, which is okay. We don't have any questions. All right, cool. And all right. Let me know if you guys have any questions, guys. I'm here to obviously help you guys and understand the application. So right now, I'm just gonna be pulling up the full stack of NFT Data Go. And let's pull it up. Let's extend it. And if you have any questions, please ping me, guys. Understand it? Okay, I'll just maximize it. Okay. All right. So, guys, so here we're just gonna go to our main file. So we have two things here. We have a React project, as you guys can obviously can see here on my left side, and then we have create NFT. So this create NFT refers to the backend. This is a backend code for us. So what I'm gonna do is I'm gonna just click this file, and it's gonna take me to the obviously to the Go file, and let's actually understand this this code. So yeah, and what I'm gonna do is, guys, now just to show how it works. So let me show you the import files. All right. So these are the import modules that I have that I did, and you guys can see right here. Obviously, these are different modules. There's crypto encoding. There's logging. There's net HTTP. That's gonna be used for obviously to get. There's different methods. So just to understand what are the HTTP servers. The HTTP server is nothing but the communication between your client and server. So you can think of as, for example, if you click YouTube or whatever you do, so now you're requesting something, you're requesting for a video, and YouTube server will actually give you a response. That's what we're going to be doing right here, okay? And here, just showing you different modules, we have asset NFT types. We're going to be actually going to be using this a lot in this. And then we have a Coreum configuration. This is the another which is used for constant, and then we have credentials, we have NFTs, we have modules, and this is used for different types, by the way. And then it is code EC types, and then here, this is our constant for sender mnemonic. I have specified mnemonic, by the way. You can also specify your mnemonic. You can also specify chain ID. So Golang is actually pretty easy, guys. I know there's so many languages, so many different stuff, and I think we have just gone through Rust and uh, uh, TypeScript. Here we're gonna go with JS and obviously with Golang. So I think pretty simple Golang code. I don't think it's really stressful, guys. It's really simple. But obviously you guys would need some practice to understand what is the Go language, what are how you guys can there's few concepts obviously, and here we have const, and you gotta as mentioned you're gonna specify your mnemonic and this and that, and then you're gonna create actually four structs. First is gonna be struct for response. The other one is gonna be for create class, mint, and update NFT. Obviously, here we're just specifying this message will be string, gonna be in message string in JSON format. Same for this, and same for our create NFT classes. We have class symbol, we have class name, and then we have class description. Similar for mint NFT, similar for update NFT data request, guys. And then we have a main function. So within this main function, what we're doing is, guys, we are actually setting up our configuration, which is to get a config, which refers a config instance for the SDK. As mentioned, we have just imported this SDK from Cosmos SDK types, and then yeah, that's what we're doing right here. We're just setting up our configuration. Really simple. I think this is really basic stuff. That's how you have to config. And here, that's the actually cool part. That's how you can actually build HTTP server on Golang. Here, we're just calling r colon equal. So this is like a short initialization in Golang. You don't have to do like let or like const. You don't have to do that, or like var. You don't have to do that. So you just have to specify r, and you can just simply say short equalization. So just to let you know, if I do this outside of it, it's gonna give us a error, obviously. And let's understand, it says expected declaration found R. So you cannot do this outside of functionality, okay? So just to give you a quick concept. Here we're just handling the functionalities. Here we're just creating APIs. I just have created this just for testing purpose, but these are the main APIs that we just created. This is the first API handling function for create class, this for mint, and this for update. Here we're just using a callback function, right? It's gonna be called only when someone is going to create an NFT class, and this is for method post. Obviously, when you are actually interacting and updating the information, you have to use post because we're not getting anything or not doing anything. So there's a lot of different methods, guys. We have get, we have post, we have put, we have delete. We have different HTTP server methods, right? But here we're just gonna be only gonna be talking about get and post, and here we're just specifying our handlers. Handler, this is basically a course. This is a middleware. So middleware is actually an important concept in backend. So middleware it's gonna allow our localhost 3000 to communicate with our backend code. If I'm not gonna specify this, it's gonna give us an error. Okay, so that's really important. Who can communicate? Which front end or which UI can communicate with our APIs? You cannot allow any UI or any front end to communicate with your backend, right? If you're gonna do that, you're gonna have a lot of problems, a lot of scams, a lot of hacking issues, a lot of vulnerabilities, a lot of bug issues. So just remember, when you're working with middlewares and API, always remember, please specify middlewares in your, whether you're working in React, JS, whatever it is, right? Whatever the concept is, always use middleware. And here we are just gonna be doing simple stuff. We're just creating a function of class NFT handler. Here we're just declaring a request that I literally just explained you that struct. We're just calling this, we're just declaring a request here. And here later on, I'm just doing some using if else conditions to show how it's working. And I am just declaring and decoding the request. Similar for this, I'm just creating a context for the client, which is used for sorry, actually, my bad. This background is used just to return an empty context. So context dot background. Within this context, we have something called background, right? This background, it has a empty context. Okay. And within this, we are going to be using for initialization tests, or maybe if there's any top level incoming requests, which obviously we will have, right? And yeah, that's basically what it's used for. And here we have four things. We have client, transaction factory, we have sender address error, and we're just doing destructuring and getting from this functionality which we have created right here. So let's go quickly and understand what is this functionality. So this is basically designed for a client context. Here we have specifying our gRPC, creating a basic manager. Here we're just obviously just specifying our gRPC client. Also, if this gRPC client or client factory was not, I mean, if we didn't set up this properly, it's gonna give us an error. Okay, and here we're just creating our client, and then we're creating our transaction factory. Also, we're just creating our sender address. That's what this functionality is all about. And this transaction factory will actually create a factory for transactions, and sender address will be needed to interact with our blockchain network. So just let me drink some water. Okay. So yeah, this is like really basic. You guys can understand by this code. I don't think it's really hard code, you know. And then yeah, let's go scroll up really quickly. And yeah, as I was explaining you, that's what we are getting. We're just destructuring and getting these information. That as I explained you, we're getting client transaction factory for creating transactions, and then we have sender address, which is going to be a sender address, and we're going to be specifying who's going to be performing the transaction. And then we have error. If there's any error performing the client context, it's going to throw us an error, right? And that's what's happening right here. We're just creating an error, and this HTTP will actually print a error, which is going to be error setting up client context. And yeah, as I mentioned on top, guys, this is asset NFT types. So this is the GitHub. This is basically called github.com Coreum Foundation Coreum version 4, because this is obviously our new feature. Uh, we are we just updated our Cord and Coreum to V4. Within this V4, we have asset and NFT types, and then yeah, as mentioned, we're just gonna be calling this asset NFT type. Okay, so really important concept. One more concept in Golang. This and asset NFT types, right? Just giving an example. So this is basically we are giving this end. This end refers to pointing out to this, right? We're just going to be getting the address where this is, because we have to specify this in Golang. And that's why we have used this end symbol right here, just to point out the address, the memory address for this asset NFT type. And we're just using dot message issue class. And within this message issuing class, we are just doing different stuff, right? We're just issuing a class. And here we're just doing transaction response, error. We're just broadcasting the transaction once the message has been issued. If there's an error while broadcasting the transaction, it's gonna throw us an error, right? As explained on the top, here we were just declaring and decoding the request. So obviously, while you're decoding the request, we have to encode, because decoding means when we're decoding, so decode is just to letting the computer or letting the machine understand, because we cannot understand, right? I cannot understand that. If I decode something, I cannot understand what is this decoded format. Okay, but for us, for humans, we have to obviously encode back, right? Just encode will actually encode back to the original format, and that's what we're doing. We're just encoding back into the message and transaction hash, which will actually gonna say if the nth response was good, it's gonna create this class successfully. If not, obviously there's no error obviously here, and it's gonna show us the transaction hash. Okay, so now we're just gonna talk about quickly about mint NFT handler. We're gonna be using same stuff, guys. Mostly, declaring a mint request. This our struct, right? And then we're gonna be declaring, decoding. This all the same stuff we have used. I don't think it's really hard, because I have already explained how it's working here. And as I mentioned, in our CosmAsm contracts, we're actually going to be using data dynamic. We're not going to be using data bytes, just because there's going to be to change or modify the NFT data. Okay, and that's what we're literally doing right here. Within this struct, we have a items. We're calling this items, and we're just specifying this as an array of data dynamic item, which will allow us to specify who's going to be editor and what type of data is going to be there. So the editor means which, I mean, who can edit this data item. We have specified this going to be your data edit owner, and similar for JSON data. Okay, so we have to specify while updating or modifying our NFT data. And once done, then we're gonna be actually gonna be serializing this data dynamic. This data dynamic, once it's created, we're just gonna have to point out the address of this data dynamic. That's what we're doing. If this dynamic, if it's not able to serialize this thing, so deserialization is just to serialize data, and let's deserialize back into the format. Okay, sorry, serialize back into the format. Here, we're just using the basic stuff. We're just building a class ID. And here we're just issuing a message, mint, read. This is our message. Who is the sender? The class ID, and data. And then we have then we are actually broadcasting the transaction here. And here we're just destructuring. If obviously there is a good, the response is good, if the transaction has been broadcasted to the blockchain, then it's going to give us a response of 200, which is a status code. We have to specify the status code, right, guys? And if the transaction was not broadcasted, it's going to show you an error here. Okay, so, and that's what we are doing, guys. We are doing similar stuff as I showed you on the top. We are here just querying the owner of an NFT. Again, we're using the error. If there is any error occur during the query, the error will be handled, and it's going to show you an error. Okay, and here, as mentioned, if you are using and if you're encoding this request, decoding the request, just to tell the machine, okay, we are decoding and declaring the request, we have to, while this server will be sending you response, we have to encode, right? Encode in a format so that UI and our user can understand, okay, this NFT has been successfully minted. And similar stuff for this. This is the update NFT data handler. We're just specifying or declaring a request. Here, we're just specifying and declaring a decoder. We're just decoding it as explained. We're decoding the request. Here, we're just creating a background again. The main part in this function to understand is this, as mentioned, while we are updating, we have to specify this asset NFT types. As already mentioned on top, this is a part of Coreum. Within this asset NFT types, we can go quickly, and we have, let me show if I can go. Okay, these are the asset NFT types. Can I go? Okay, it's not letting me go. Okay, no worries. Okay, no worries. Okay, so within this asset NFTs types, guys, we have so many types. We have literally message mint, we have build class IDs, we have message issue class, we have so many different types, right? And here we're just using data dynamic, as already explained in contract as well. We have to use data dynamics and data dynamic item just to just to tell you guys again so you guys don't forget. And here we're just including it again. And here, once you have specified everything, and then obviously we're going to be using a message to update the data, right? Who's the sender? What is the class ID? And what is the items? And then once you have the message update data, and obviously you're going to be broadcasting the transaction. Okay, so now, guys, I think this is your Golang code. I think I have explained you really proper in a really proper manner as much as I could, right? And okay, so now you have created this file. Let me just say, let me just do this. Just give me a second, guys. Sorry about that. Okay. All right, cool, guys. So let's go to the this was the backend code. Now let's go to the front end code, right? We have to go to the front end code. Now, because our URI, as we have specified right here, the port will be 8080, which I have already specified. This server is actually running and listening to 8080 port, right? And within our application in React.js, we're gonna create an API.js file. Within this file, we have different functionalities. Okay, first is for create an NFT, mint NFT, and to update NFT. Okay, so Axios, we are using this Axios, which is a module. And in this module, we have so many different stuff. Yeah, we're gonna have so many different methods out here, you know, and you guys can see right here. There's so much stuff going on. Get URL, patch, post. There's so much stuff on in Axios. Really good module. Very good. I actually use a lot for backend and for if I want to have if I create a backend, and obviously I use Exodus a lot. One thing to give you a really good knowledge, guys, when you're actually talking to the backend or database, you always have to use try and catch, and try to use asynchronous as well. Okay, so this try catch will actually, within this try, we have this response for for updating our create class, and we're using this class data, and we're going to be returning this response data, right? And here we're just going to throw error if there's any problem by creating a NFT class. Similar for mint NFT, we are doing axios.post. We're giving this API based URL. As I mentioned already, this main goal will be running on this local host, and within this, we're gonna have to specify it. We have to specify this NFT data, and we're gonna be returning this response. Similar for update NFT data. Okay, guys. So let's quickly go to the application. So this is like an application, you know, and here we're just gonna be applying a lot of CSS, a lot of state management, a lot of toast. So we're gonna be using also React Toastify just for success and for error conditions. On top screen, you're gonna be seeing a toast container showing you success and error conditions. So that will be I'm gonna show you later on. And here we're just creating a function. Within this function, we have a lot of state variables. We have, as mentioned, we have class data, NFT data, and update data. And here is to create NFT class. This one is to create NFT mint, and here is to handle and update NFT data. Okay, guys. So yeah, this is going to create. Sorry, I forgot to mention this. So I'm actually importing these functionalities from this API, right? As I mentioned here, we have different functionalities. I go here. I'm just importing these library. I'm just calling these functionalities from my API JS folder, and similar. I'm just importing all the necessary stuff, and yeah, and that's what we're doing, guys. Here we're just calling within this our create class. We're just calling this create NFT class. We're just specifying this state variable, and here we're just specified it. It's gonna just log the response. Here it's gonna save, or it's just gonna show us these success conditions. Okay, so that's the open and really cool stuff. So let me show you how it's actually gonna be working. I'm just running my backend now. Okay, showing no such file. Okay, obviously because I haven't specified it. When I specified it, and I'm gonna say go run main.go, which will be running our backend, and I'm gonna show you a really cool stuff. Okay, hopefully you guys are able to see this. Now I have actually already created these commands. Okay, I will be going back to my VS Code again. So if you guys can see my terminal, let me do this. By the way, guys, my backend is already running at this port 8080. So now I'm actually gonna show how you can test the APIs, right? So this is a really cool command which is be used really just to test the APIs. Actually used a lot of she's used a lot. You can also use Postman, but it's a really cool way to test your APIs. And boom, um, once I'm gonna enter this, it's gonna hopefully it's gonna show us a response. It's gonna take a little bit of time. It's gonna take a little bit of time, guys. Hopefully, if not, then I will just exit the terminal again and just do it again. Okay, it's taking a little bit of time. No worries. We're just gonna do it again. Okay, account has been mismatched, showing us an error. No worries. We're just gonna change our. We will just change our class symbol, class name. That's the actual error. Okay, no worries. Now I have entered again. It's just running, it's taking time. Maybe I don't know if it's my internet. No, it's not. Okay, still not able to do it. Okay, let me exit again. Okay, the transaction estimation has failed. No worries, we're gonna change the class symbol again. Hopefully it shows to us. Okay, let me maximize it. Let me actually clear it so you guys can understand. Yeah, it's taking a little bit of time, you guys. Maybe I can just run my server back. Just gonna clear this. Sorry for this inconvenience, guys. I am gonna just clear my port. I'm gonna say 8080. We're gonna just say kill 9. The port number is 9242. Boom. We're just gonna kill, as mentioned, it's already showing us, so which is good. And now I will run my okay. No worries, I'm gonna just run my file. Go run main.go. Now it's gonna run the server for us. Okay, it is showing that it's already been used. Okay, I'm gonna run my file again. It's gonna run my server again. Okay, it's showing me error again. Okay, I'm gonna copy again. Sorry about that. I'm just gonna run this again. Okay, let's close this. I don't know why I'm having this issue, guys. Maybe I just restart my quit. Just gonna see. Okay, guys, we're gonna run again. Okay, we're just gonna go to the create NFT. Okay, the backend is working, which is good. We're just gonna create again just to test out the APIs. I will show you how the front end is also working. Just to let you guys know, we're just gonna copy this. We're gonna go to the backend. Just gonna paste this API command. Gonna test it out. If not, we're just gonna test it out from the UI then. Okay, it's showing me. I think maybe it's my network issue or whatever the issue is. We're just gonna change the class symbol. We're just gonna try it again. Okay, the account has been mismatched again. $981. We're just gonna change this to $981. $981. We're just gonna copy this command. Okay, let's try with our API. Let's try with our UI. Okay, let's copy this. Now I'm going to show you how it works right here. We have different functionalities here, obviously. So here you can just say anything, right? NFT data one, where you can say class name. As mentioned, the backend is working. The front, I just started my front end. You can say NFT data two. Class can be say hello, guys, whatever you guys want to say, right? And we're just going to create a class. We're just gonna create, let me just maximize it. Okay, let's actually refresh it. NFT1, we're just gonna say hello guys again. T2, we're just gonna say create class. Okay, let's see what the okay, having some RPC error issues, guys, so let's wait and I have refreshed it again. Hopefully it's gonna create a class again. Okay, now as you guys can see right here, this actually have created a class. So now we're just gonna go ahead to the Block Explorer. Let me just delete this. Let me copy it. Let me just, as you guys can see right here, that the NFT has been issued as mentioned in our UI, right? And now what we have to do is, guys, we just have to copy our class symbol, and we're gonna go to our mint NFT. We're just gonna refresh the page so we don't have any issue. We're just gonna pass in this. We're gonna say hello 23. We're gonna say J, and we're gonna say best blockchain community or whatever you wanna say. Right, I have just specified this. Now I'm just gonna mint NFT. Same error actually. Just gonna refresh it again. And we're gonna say NFT 23, say J24. We're gonna say hello, the best community, and we're just gonna mint it. We're just gonna mint the NFT, guys, and yeah, there's some issue with the RPC, guys. So let's try it again. Let's give some time. Let's see the error. Yeah, there's some RPC error issue going on. So apologies from my side, and not from my side, but this happening on the RPC. So let's do this again. NFT 77 J testing. We're gonna say hello community. We're just gonna try again. Okay, there's issue again. Yeah, there's RPC error issues on the testnet network. It mints it, but it's not doing the. I mean, it created a class for us, but it's not able to mint it. So Let's wait, you guys. Let me refresh it again. Let me refresh or maybe run my again. Sorry about this inconvenience, guys. Happens, right? We're just gonna kill our port just to clear out some things. We're just gonna run it again. Right, boom. And we're gonna say npm run start. Okay, it has started. We're gonna go to the blockchain explorer that we just issued the class. Okay, the issue class. We're just gonna get our issue class. We're just gonna get the symbol, which is right here. We're gonna go to the NFT. We're gonna say unique 77. We're gonna say J testing hello community, and we are just gonna be minting. I just have pressed it. Okay, there's some issues. So yeah, guys, there's some issues on the RPC. Nothing wrong with the code, by the way. Nothing wrong with the code, but as you guys have seen that on the CosmBasm side, everything was working. But here is not working, so all good. No worries, no worries. It happens. As mentioned right here, it's the RPC error. You see right here. So all good. Okay, you need this. Hello, tutu description. Hello, world. We're just gonna mint again. Try again. Okay, boom. Now you guys can see this transaction hash is being successful. I think there is an issue with the RPC. As you guys could have seen that RPC that was showing a lot of RPC error. So maybe there's a transaction. Okay, as you guys can see, the NFT has been minted. Now what I'm gonna do is I will actually just copy this class symbol, and as you see that NFT has been minted, we're just going to pass in our class ID. We're just gonna specify our NFT ID that we just minted, and you guys can see this NFT minted. This is our NFT ID, and boom, we're gonna go here. We can just say J again. We're gonna hello world. We're gonna say the best, and now we're just gonna update the NFT data, and boom, the NFT data has also been updated. Now you guys can see how everything is working fine, right? Error. Look, when you guys are coding, whoever codes it, I understand there's issues, but there was a blockchain network issue, but now everything is working fine. And boom, now I'm gonna search this transaction hash. Now you guys can see, boom, the NFT has been updated. This is our data, right? I'm gonna go to the base 64 and I'm just gonna decode it. As you guys can say, J again, description the best, right? That's what we have specified right here, J again, and the best. So yeah, guys, that was the workshop on full stack Go. I showed you how you guys can do it on Golang, how you guys can interact Golang with your application, how you can write smart contracts, how you can interact with smart contracts with your application. So hopefully you guys enjoyed it. I know this is a little bit long workshop, but hopefully you guys understood it, and hopefully there's no issues. Yeah, now obviously there is a repo. You guys can clone these repos, and you guys can do a lot of different stuff with this. Play with it, change it, create NFTs, modify NFT data, and yeah, guys. Now let's go to the questions. If anyone has questions. Uh, Okay, so there's a question, Chris one. Can we still apply the same message logic to have a mutable such a claim? Yes, you can. Can we choose multiple metadata fields to change based on specified user actions or display dynamic values on the NFT itself from database values? Where do we specify this? Thank you. Sure. Yes, that's actually a good question. Um, so now you can, but depends where you have to go. I mean, when you're updating data, remember this, you have to specify this is your JSON data, right? What's your name? Sorry, Chris. So if you see right here, we are specifying this JSON data in our Mint NFT handler. As mentioned, you have to specify data dynamic, and you can just specify this JSON data in a array format. I'm specifying only name and description. You can do whatever you want, right? I mean, you can specify features, whatever it is. Okay, that's how you can also specify. I don't know if I just said message logic such as a claim or unclaimed item connected to, yes, indeed it is connected to specific ID, as I showed you how you can get from the block explorer. If I showed you right here, this was where you always have to mention class ID and NFT ID while updating your NFT. Obviously, in blockchain, you have to specify with class ID and NFT ID, and that's how you can I mean, that's how you can modify your NFT ID. I mean, sorry, I'm saying ID. My bad. NFT data. So that's how you guys can. That's how you can do it. And within our smart contracts, you can do the similar thing. You guys can modify however you guys want to. Hopefully, it answered your question. I mean, yeah, hopefully I answered your question. Learning is fun. Indeed, it is. Indeed, it is. So, yeah, guys, I don't know if anything, if there's any else, other questions from my side. I mean, I don't know if there's any questions from you guys. Hopefully, you guys enjoyed this workshop. I know there was a lot of tons of knowledge, but this will definitely help you build a better developer. I have actually given you a lot of new concepts. I think we're doing for the first time with Golang. So hopefully you guys understood what I was telling you guys. If not, I am on Twitter, obviously. Um, it'll be uh, it'll be really good. If you have questions, just ping me on Twitter. Would love to give you any any answer, And from next week, we're gonna have a workshop tomorrow. Obviously, we have another workshop with subquery. It's gonna be a cool workshop. Quick workshop, I think, is gonna be 30 minutes. Now we're not gonna take that long. We're just gonna have a quick and how you guys can index and query data in the blockchain. I did okay. So there's a question. Thank you. I did some play around with your guys' new random generator to add NFC IDs, but this was the great add to specify. Thank you for your time and for the answer. Thank you, Chris, for understanding. I'm always on Twitter. Ping me if you have any other questions. We'd love to help you guys out. All right, y'all. See you guys tomorrow. I'll be doing another workshop tomorrow with the subquery team. And next week we're gonna have a developer community calls. We're gonna have a Twitter space. Well, you guys can join the call, and then if any questions, we can just give you live. We're just gonna be there, gonna give you answers. Uh, so yeah, guys, thank you. Thanks for tuning in. I really appreciate you all. And yeah, see you guys tomorrow. Thank you. Bye.